of the redox in acidic solution. I have 3 examples here. Let's try this one. So it's gonna be lengthy, so we have to choose only 1 or 2. It depends on the situation. Okay, so this is it. Pancit. Okay, we need to have example for the proper understanding of redox in acidic solution. Okay, number 1 we have example. So like this. Okay, iodide. So example number 1, right? Oh, nakakaloka. Iodide, -1 charge, right? Plus, what's this? Bromate, BrO4. Be careful also because in redox sometimes it will be given in a statements or words only, and you have to put the chemical formulas. Then if you don't have an idea, then nana. So we need to familiarize the chemical formulas, symbols, elements, compound, whatever, something like that. Okay? So we have the product will be iodine gas, I2, okay, plus bromide. Okay? So what is the first step? Obtain the oxidation number or the oxidation state. So like that. So in case of bromate, okay, bromate is polyatomic anion, as I told you, and a salt, like that. Okay. Okay. So this is polyatomic anion. So this overall charge is equals to -1. Then assign negative charge to -2 for oxygen, and let X the charge of bromine as the unknown oxidation state of bromine. So we will say in oxidation principle calculation, we will say X times the subscript of bromine, which is 1, plus -2 charge times the subscript of 4 is equal to -1 overall charge of bromine. Then solve for the value of X. So X -8 is equals to -1. X is equals to -1. Transpose the 8, -8 to the right, it will become positive. So it will become X 1 minus -1 plus 8 is equals to 7. So this is the oxidation state of bromine, 7. Positive 7. Okay, now erase. Obtaining the oxidation state, step 1. Okay? And then, for iodine is a solid gas. Okay? You got the point mga palangga for the iodine. Okay? Iodine has 129.90 gram atom molecular weight, no, atomic weight, or atomic mass. Okay? You get the point. So, fluorine, chlorine, bromine, iodine, astatine, right? In the group 7A family. Okay? If I'm mistaken, yes. 7A. Okay, so this is 0 for single pure substance iodine gas, diatomic iodine gas, and then the bromine is already negative. Okay, here. Okay? So no need to like this. Okay? Put X here, no need. It's already the charge, right? Now inspect. Okay? For your iodine, the change is from -1 to 0. So there's an increase of, I just put arrow up to make it save the words. Okay, so arrow up, increase the oxidation state or the charge. So positive, okay, 1. Okay, increase in positive 1. And then this is, since it is increasing, this means loss of electrons. Okay? Meaning loss of 1 electrons. Loss of 1 electrons. Okay? Get the point. Okay. And this is oxidation, low ox. Okay. And then, if it's increased oxidation number, then your iodine is oxidized. And then, therefore, your iodine is a reducing agent. Okay? Iodine is your reducing agent. Ganon. Okay? Reducing agent. Could either be an iodide with negative 1 or iodine gas with a charge 0, as long as it is iodine. Okay? Reducing agent. Okay, now, okay, determine the other one, the reduction. So let's inspect. Okay, here we have no oxygen in the product, so don't do that. Okay, but we have bromine in the product, so take the whole thing here, bromine. Okay, so positive 7 and negative 1, so these are decrease of the oxidation number. Okay, decrease in oxidation number of, it's gonna be 6, right? From 7 to negative 1, so 6, right? So there will be a gain of electrons. You get the point, because it has been decreased the oxidation number. So gain of how many? 6 electrons. Okay? From positive 7 to negative 1, so gain 6 electrons. This is going to be reduction. Okay? And then bromine is reduced. Okay, reduced. Okay? Then your bromate is your oxidizing agent. Okay, oxidizing agent. Okay, like that. Perfect. Now we go now to number 2. Go to the oxidation and reduction equation. Okay, in here, what is your oxidation? It's here, right? It's the iodine thing. So put here oxidation. Okay, oxidation reaction, or let's say the half oxidation. Okay, reaction. Half oxidation reaction is just simply saying oxidation reaction. It's just the same. Okay, so start with I negative and I to 0. Now since this a loss of 1 electron. Okay, as I told you over and over again, guys, that the loss of electron actually is going to be, for example, for the purpose of discussion, okay, before we will not we cannot afford to go directly. Okay, so iodine negative 1, iodide, right? This is loss of electrons. Actually, this is minus because it's loss. Minus of 1 electron. Okay, since there's no minus in chemical reactors, always positive, that's why we need to transpose that to the right during the half oxidation reaction. So that's the clear thing that most instructors fail to teach the students. Okay, why the electrons will be going to the right? Okay, because if it loses the electrons, that is negative. So it will become positive when you transpose that to the right. That's why the electrons will be added to the other side. Okay, and that's very clear. That is for the oxidation. Okay, take note. Iodide, negative 1, then will be equal to, so iodine gas. Okay, like this, iodine gas, and then plus na siya electrons on the right, on the theory. So how many electrons have been adding? Yes, then iodine, okay, we have now, it's only 1. So plus 1 electrons. Okay? So I negative 1 plus I2 plus 1 electrons. Okay? You can put directly. This is the first method. You can put directly in oxidation, or you can compute by using math, algebraic addition of the charges, but later on only. I will discuss the other alternative. Okay, now first balance the atoms. Right? Balance the atoms. How can you do that? Okay. 2 iodine, and there's also iodide here, negative 1, so put 2 on the iodide, right? Okay, like this. So balance the atoms already. Now, balance the charge now. Okay? You get the point, mga palangga. So, it's gonna be like 2 times negative 1, negative 2, and then 0 plus 1 negative. Okay? You get the point, mga palangga. So in this case, mga palangga, we don't have to add directly the 1 electron here because there's a moles of I2 gas here. You get the point? So anaunin mo siya, guys, sa atoms. Okay? Because it will not balance directly. Okay? So we need to put the plus, ganan, plus X as our number of electrons. Okay? Because if we put the electrons directly based on our step 1, it will never be balanced. the charges. The atoms will balance, but the charges will not balance. Okay, here, 2 iodine balance, I2 balance, 2 atoms both, and then electrons. Okay, 2 times negative 1, balance the charges. Okay, negative 2. Okay, here, iodine is 0. So 0 plus x. X is our number of electrons to be solved. Okay, algebraic type. Okay, then we will say x is equal to 2, right? X is equal to 2, then therefore x is equal to 2 electrons. Then these 2 electrons will be added here. In your equation, remove the x, okay, like this. So put here, like that, right? Okay, here. So 2 electrons mga palangka, okay? Like that. Now prove that if it is balanced really, okay. 2 times negative 1, negative 2, charges 0, then 2 electrons is negative 2, right? 2 electrons, because electrons is negative, so this is balance. Okay? Ito point mga talangga. Okay, balance siya. Okay, it's gonna be your half reaction, oxidation half reaction, 2 iodide equal to iodine gas plus 2 electrons. You can put the 0 or nothing, it's just the same. Okay? Above the iodine gas. Okay, that's it, pancit. Equation number 1. Okay, go now to the reduction half reaction or half reduction reaction. Okay, half reduction reaction. Okay, ganon. So we have here, so in this case, we need to bring all the bromate down because we cannot split here individually because this is solution. Okay? Solution. Redox in acidic solution. Okay? Okay. Ganon. You cannot split, right? So put the bromate here. Okay? Bromate. Bromate. Okay. Now it's stated here, okay, reduction, meaning gain of electrons. So therefore, we can add electrons directly beside bromate because gain. Okay? And we don't know yet the electrons. Okay? Try to transfer directly what is being gained in this equation. 6 electrons, right? Let's assume. Okay? Because if it will not be balanced, let's use algebraic expression to balance the charges. Okay? Like that. Okay, then bromate, then go to the other pair which is bromide. Ganon. Bromide, negative. Ganon. So first, balance the atoms. Okay. Okay, oxygen 4. There's no oxygen 4 in the bromine. Bromine is balanced, 1 mole, 1 mole. So we need to add, since this is acidic solution, we need to add 4 moles of water. So 4 moles of water. Then the rule says if you add 4 moles of water, then you have to add H plus in the left. The H plus here is simply 4 times 2, the atoms of hydrogen. And it's gonna be 8 hydrogen positive 1. Okay. Now balance the number of atoms and the charges. 8 hydrogen, 4 oxygen, bromine, balance. Now balance the charges. When we mean balance the charges, guys, it includes electrons, the adding of electrons by either the left or the right, so that it will cancel out, something like that, okay? Okay, now, charges balance. So, H plus, so 1 times 8, so 8 plus. Bromate, okay, bromate is negative 1, right? So, negative 1. So, negative 1 times 1 is negative 1, okay? 8 plus negative 1, okay? And then 6 electrons plus 6 electrons is equal to bromide negative 1 times 1. Negative 1 times 1, because nothing means 1 in chemistry, okay? Like that. Plus, okay, what is the charge of water? This is neutral compound. If you don't put charge at top, or not a polyatomic and ions, it's gonna be 0. So 0 times 4. Meaning the coefficient. In charges balancing, we need to take note that that is the charge times the coefficient beside the elements or beside the compound. Or charge times the number of moles beside the element and beside the compound. Okay? That's very clear, right? Okay. So add 8 minus 1 is positive 7. Positive 7 plus 6 electrons is equals to 1 because 6 is negative. Electrons is negative. So therefore 7 minus 6. So is equals to 1. Okay? Positive 1. The total net charge of this left reactants. Now on the product, okay, like this on the product, okay, negative 1 times 1 is negative 1, right? So 0. So 1 is equals to negative 1. So this is not balanced. Okay? So if this is not balanced, now another method will apply. Okay? So remove the 6 electrons. Let's do algebraic. Okay? Balancing. Okay, let's put this as an X. Because this is gain, the electrons will be in the left. Okay, so plus X. And X is the number of electrons we need to solve. Unknown. Okay, like that. So revise this one. I do this because sometimes, if you put directly, the gain and the loss of will just be balanced. But there are some cases that cannot be balanced immediately. That's why we need to do the algebraic expression of solving the number of electrons. Okay? Ganon. Nakakaloka. Diba? Okay. Wait mga palangga. Okay? Ganon. So, 8 times positive 1 is 8. Positive 1 times negative 1 plus X because unknown number of electrons. Okay? So, negative 1 times 1 for bromide is negative 1 plus 4 times 0 for neutral compound, 0. Okay, so for value of X. So 8 times 1, 8. And then 1 times negative 1 is negative 1 plus X is equals to negative 1. 8 minus 1 mga palangga is 7. Okay, plus X is equals to negative 1. Then therefore, X is equals to negative 1. 7 will become negative, right? When transpose to the right, so negative 7. So electrons is negative, right? So this is negative 8 electrons. This is negative 8, so this is 8 electrons. So put 8 electrons here in the X. Okay? And then balance again if it is balance the charges. Okay? If the charges will be balanced, then proceed. Okay, balance again. Like this only, right? Okay, so we have 8 times 1, 8. 1 times negative 1, negative 1. Then 8 electrons plus 8 electrons. Ganon. So 8 electrons plus 8 will just be equal to 0 or negative 1. Okay, like that. Okay, so positive 7 minus 8 electrons is equals to negative 1 because 8 is higher than 7. Okay, here on the other side, negative 1 times 1 is negative 1. Oh, 4 times 0 is 0. So perfect, balance. Negative 1 total net charge of the reactants and also negative 1 in the product. So balance. Proceed now to your overall redox in acidic solution. So this is now your equation number 2. Okay? Equation number 2. Okay, now add the two half reactions, the oxidation and the reduction. 1 plus 2. So equation 1 plus equation 2. Now, take note with the number of moles, number of electrons. Because already balanced the atom siya. Okay, so electrons. So the first reaction or equation is 2 electrons, the second one is 8. So it cannot be cancelled. So find a number that will be multiplied that it will be cancelled. Okay? So if it is 8, so we need to multiply by 4 this oxidation. Okay, times 4 the first equation. So times 4, like that. So it will become 8 iodide is equals to, 4 times 2 man siya. So 4 iodine gas plus 8 electrons, right? Yes, equation 1 finally. Equation 2, no need because it's also 8 electrons. Just copy directly. So 8H plus bromate. Okay, mga palangga. Claro, okay, is equal to plus 8 electrons pa siya, and then equal to bromide, okay, plus 4H2O, equation 2. So cancels the 8 electrons because they are in opposite direction. 8 electrons in the left and 8 electrons in the right. So this will be our final H plus, this one, bromate plus bromide plus 4H2O. Copy your overall redox reaction and balance again the number of atoms and the charges. Then bingo. If it is perfectly balanced, both the atoms and the charges in your overall net reaction of your redox in acidic solution, then bingo, that is your answer. Okay? Like that. So I will erase this one, transfer this one, right? So let's check and balance the atoms and the charges and electrons. Oh no, charges, no more electrons because it was cancelled. Okay? Like that. So transfer carefully here. So we have 8H positive plus bromate, okay, plus, okay, like that. And then a bromide, nakakaloka, plus water, okay, ganon, okay, like that, okay. You get the point mga palangga. So, plus, reactant niya siya, so 8 iodide, okay, and then plus 4 iodine, okay, plus, okay, like that. So, na-cancel lang yung electrons, right? So, it's gonna be 4 iodine. Okay? You get the point? Something like that. Now, balance this entirely. First, atoms. Okay, 8 hydrogen. O, 8 hydrogen 4 times 2. Okay? Bromine, 1 mole. Bromine also 1 mole, right? Oxygen 4. Oxygen 4 is also balanced. So, perfect. Atoms in both sides are perfectly balanced. And now we go to the charges. Okay? 8 times 1 is 8. Plus 1 times negative 1, negative 1. So 8 times negative 1 is negative 8, right? Okay, this is gonna be 8 plus negative 1 times negative 8 is equals to positive 8, right? Am I correct? Okay? You get the point? Or not? Okay, it's gonna be like that. Okay? So, muna yung mahitabo. Okay, so like that. So 8 minus 1 is equal to 7 minus 8. Actually guys, this is PEMDAS already. PEMDAS rule in algebra. Meaning, start where the parentheses, okay, and after that, exponent if there is, and then third, multiplication, fourth, division, fifth, addition, last is subtraction. This is the rule in algebra. In this case, if I will proceed to multiplying directly these two quantities here, it will become wrong. So I will say it start here. See, negative 1 minus 8, right? It is negative 9, right? Something like that. And then you will add later. So in the PIMDAS, which comes first? Right? It's the parentheses. Okay, so we need to say, you need to add first this negative, not subtract. Okay? Because PEMDAS, the addition comes first, subtraction is the last. So you will go to the left first. So 8 minus 1, not negative 1 minus 8, you will be wrong. Because it doesn't follow the PEMDAS rule in algebra. Be careful with this. Because it doesn't have the same answer if you try to start with the right. Okay? So add first. Because there's no multiplication here, there's no division here, right? Okay? Get the point. So 8 minus 1 is 7 minus 8. Therefore, negative 1. Total net charge of the reactant. In the other side, okay, I have 0. Okay, 0. And then 4 times 0 is 0 for water. Negative 1 for bromide times 1 is negative 1. And then for iodine gas, the charge is 0 also. 0 times 4 is 0. So cancel the 0. Negative 1 also. So net charge of the product is also negative 1. Therefore, negative 1 is equal to negative 1. So perfect. This is your redox chemical reaction in acidic solution finally. we obtain 8H positive 1 plus bromate plus 8 moles of iodide is equal to 1 mole of bromide plus 4 moles of water from the reaction of iodide plus bromate, okay, is equal to iodine gas plus bromide. Okay? It's gonna be like that. Okay. You got the point, mga palangga. Okay. You get the point? That is example number 1. Okay. Thank you so much for this example. I hope you understand the discussion regarding the acidic solution redox. So you can comment down below in the comment section, and you can like, and you can also share, and then you can subscribe to my channel if you want also, and then you can wait for me for another vlog. Okay, and then click the notification. Okay, ganon. I'll be coming back. God bless everybody. Ganon. Kaloka. Diba?